All right, day 7 of Trig, and I think you're going to like today's lesson. So today we're going to look at horizontally expanding and compressing sine and cosine functions where the b value is some quantity of pi. So we'll dive right into this. So the first function, we've got the sine of 2 pi over 5 times x. So our b value here is 2 pi over 5. And how does that impact our period? Okay, well, our period formula is 2 pi divided by b. And if b in this case is 2 pi over 5, then our period is 5. Okay, so how do we graph that? Well, it's going to look a little bit different, possibly a bit easier. So we're going to relabel the x-axis as y equals q, which in this case is 0. Our max is 1. Our min is -1. It's a sine function with no phase shift, so we're starting at a midpoint right here. Now what I'm going to do is I'm just going to put a hash mark here and call this 5. So within that we would have 1 period. And I'll try to do another one about equidistant, and we'll call that 10, and we'll get another period there. But what I'll do is within those periods, I'll break them up into 4 equal parts. So we're just cutting in half and then cutting the halves in half. And then we can plot the rest of our significant points. So we've got a max, mid, min, mid, max, mid, min, and mid. And we connect the dots. And there we go. There's 2 periods of the sine of 2 pi over 5 times x. Okay, we'll look at another example here. So our b value is 2 pi over 100. What impact does that have on our period? Well, we've got 2 pi divided by 2 pi over 100. So we have a period of 100. Okay, we will label. We've got 0, 1, -1. This is a cosine function with no phase shift, so we're starting at a max point. And again, I'm just going to label this as being 100. I'll label this as being 200. And we'll break each of those periods up into 4 equal parts for our sig points, and we will plot those sig points. And there we go. So there's 2 periods of the cosine of 2 pi over 100 times x. Now let's see if we can work with something a little bit more complicated. So here we've got y is equal to 3 times the sine of 2 pi times x minus 2 over 4 minus 5. So I'm just going to put a little box around this because I'm going to focus on simplifying this a little bit into something that's going to make a little bit more sense for us. So let's rewrite this. We've got y is equal to 3 times the sine of. Now I'm going to factor a 4 out here. I'm actually just going to rearrange the way this is written. 2 pi over 4 times x minus 2 minus 5. Okay, so let's go through and start to graph this. Our x-axis, y is equal to -5. Okay, our Our amplitude is going to be, or our max value is going to be 3 above this. So our max is at -2. And our min value is going to be 3 below this at -8. Okay, we have a starting point of 2 units to the right. We'll call that 2, and it's a sine function, so we're starting at a midpoint. Okay, now our sig points, let's determine our period first. So t is equal to 2 pi divided by b, and b is 2 pi over 4. So our period is 4, and so our sig points will occur every quarter of a period. Period's 4, divided into 4 equal parts. Our sig points occur every 1 unit. So we've got 2, 0, 1, 2. We'll label some more points. 3, 4, 5, 6, 7, 8, 9, and 10. That should be more than enough. Okay, and it's a positive sine function, so it would increase to begin. And we can plot the rest of our sig points here. Connect the dots on our sine curve. And we get something like that. All right, and the last question for today, quick lesson today. So the volume of air in one's lungs is a sinusoidal function. So sinusoidal, again, meaning sine or cosine. And we'll make a determination on which we use in just a second. So the volume of air in one's lungs is a sinusoidal function of time. A graph showing normal breathing is shown below. Determine the equation for this function. Okay, now if we use this point here, if we use this point here as our starting point, then we have no phase shift. We're starting at a time of 0 seconds. So that is probably our easiest bet, and that's a midpoint. So let's select a sine function. So we're going to go y is equal to a times the sine of b, and I'll write this in times x minus p, even though we already know that there's no phase shift. Okay, so we got to determine a, b, p, and q. And we already know that there's no phase shift, so p is 0. Okay, so the easiest thing to find would be the vertical displacement, and there are between 2200 and 2700, there's 500 units there, 500 milliliters, and if we cut that in half, that's 250, and then add it to our min, so our Q value is 2450, and the amplitude is 250. Okay, and so what we need to find here is what is our B value? Okay, and so that's going to be related to our period. And let's see here, this is one period here. 1, 2, 3, 4 boxes. And if we look at our horizontal scale at the bottom, 4 boxes is represents 5 seconds. Okay, so our B value, or our period, is 5 seconds. Our B value is going to be 2 pi over 5. So if we put this all together, our equation looks like this. Y is equal to 250 times the sine of 2 pi over 5 times x plus 2,450. And that's it.